Okay, I think most of us are here now. So we are now officially starting this session. Turn on screen sharing like that. Okay. The topic today is step-by-step instructions how to import 3D survey point clouds, 3D meshes, and orthophotos into AutoCAD. I guess this topic is very interesting because we had, I think, the most webinar registration so far. So let's quickly go through the demonstration. So the overview of today's session will be, first we will define the problem and solution. We will look at why do we need to even bring this data into AutoCAD, and then we will jump right into it. So we will be looking at how we can import the point clouds, meshes, and orthophotos into Civil 3D. We will also check about X-rays, how you can bring those in. And then for the third part, we'll also be looking at some additional tricks that can be done, like importing vertical cross sections and contour lines. And then we will also be looking at how we can import the points in Dxf format and how we can convert those points from one coordinate system to the other. And then the final part of this webinar will be a Q&A session. So I think that this webinar will probably take around 1 hour. So I have about 50 minutes of material, and the last 10 minutes we have reserved for the questions and answers. So if at any time during this presentation you have any questions, just write them in the question box, and at the end of this session we will go through all the questions and we will answer them. So right now let's continue on to the next slide. So for a little bit of introduction, so why do we really need to bring data from 3D survey into AutoCAD? I'm sure most of you can also answer this one. So we, land surveyors, we must make survey maps and we give those survey maps to our clients, who will be architects or civil engineers. And most of the time they are using some sort of CAD software. And then in order so that we can give them the data, what we usually do, we make a CAD drawing and we hand over our results to them that way. With the drone photogrammetry, we get a lot very useful data, like very detailed 3D models, point clouds, and orthophotos. And if you ask me, it would be a shame not to share those data with our clients. Because of that, we are making this webinar today. So there are many different CAD softwares available worldwide. I'm most familiar with AutoCAD, and in my part of the world, most surveyors also use AutoCAD. I know, for example, in United States, a lot of people use Carlson. I hope that some of these techniques that we show here you can also apply to, for example, Carlson software, or maybe to some other software like BricsCAD, FreeCAD, ZCAD, ZVCAD, I don't know. Okay, let's go now to the first session. Let's check how we can import point clouds into Civil 3D. Okay, now let's have a look at how we can import a point cloud into AutoCAD. So here I have a pretty nice example of a point cloud. It has some 46 million points, and now we will be looking at how we can bring these points into Civil 3D. So the first step will be, here we need to export an LAS file from 3Dsurvey. So pretty straightforward. To do that, we just go to point cloud and use save as, or just right click here, save as, and we will save it into LAS file format. So I have already done that, and that's pretty straightforward. The process will take a few minutes. We are actually right now working on an update that will speed up this export by a lot, so it will make it a lot faster. But here I already have it, so we'll just skip this part. Then step number 2, we have to prepare that LAS file for use with Autodesk products. So the first step will be, we will import that LAS file into Autodesk Recap. So we will need this recap for that. Now, right now there are two versions of Recap available, Recap Pro and Recap Free. So according to official Autodesk webpage, to get the free version of Recap, we must download and install Recap Pro and use it in trial mode. So after the trial period is over, the license will be automatically converted to Recap Standard, a free version, which has limited functionality, but it has one important function. It will allow us to import LAS point clouds and convert them into Autodesk proprietary RCS format. So let's check it out. I have here actually an older version of Autodesk Recap, so this one is from 2016, and in this one, so this is the window that pops up right after you open it, and here we will go to new project. We will select city model, city point cloud for the project name. Now here we will select the LAS file that we want to use. Go here to where I have my city project. So this is the LAS folder we would export from 3Dsurvey, like that. Now it's all ready, we click just here index scans. So basically this is it. So what is happening now? The LAS file is converted into Autodesk format. So while this is loading, we can have a look at this point cloud in 3Dsurvey. Just increase the point size slightly to make it more denser. It's pretty amazing, right? So this can be a small teaser, but we are testing some new solutions with 3Dsurvey, and for city mapping, well, you know, land surveyors, we were always obsessed with the curves when we are measuring. So now it looks as if finally we will have a technology that will allow us to measure these curves from photogrammetric data. So here, if we look closely at this model, we will notice that it is pretty accurate, so we have the details in very high definition. Amazing, right? Let's check what's going on with our import into recap. It's 100% complete. Let's launch the project. So here it is. We are now in recap. So here, if we want to rotate the project, we use right click. So the free version of recap will allow us to visualize the model, and we have here one important function, export. So that's this one. Click on this, and now we need to save this into AutoCAD RCP data format. Go to project, city, point cloud, RCP, save. A single yes, let's go. So now this one is exporting again. Okay, the export has just completed. Now we can move to Civil 3D. So yeah, as you noticed, this part of presentation is pre-recorded. That is, to help so that we don't wait for this import and exports and those kind of things. Okay, now in AutoCAD, we will simply use point cloud attach function. The easiest way to do that, we just start writing PC and we get this one, PC attach, or you can use the long version, point cloud attach, select. Let's move to our folder where we have our RCP file, select that one, double click on it. You get the standard import window. So insertion point, we will keep it at 0, 0, 0, scale 1 and no rotation, zoom to point cloud so that we don't have to use zoom extends command. Okay, and here it is already. If we rotate it slightly, so the navigation in AutoCAD will be slightly harder than it is in 3Dsurvey, but we should still be able to use this one to draw some basic lines. So here is our point cloud in Civil 3D. We could now, if we go here to point snap options, right click on it, object snap settings. So here we have 3D objects set, so we will be snapping on nodes. We want this one turned on, and now if we just start drawing line, we can draw on this point cloud. So we did a similar webinar back in 2016, I think it was. Back then, when we imported big point clouds into AutoCAD, it didn't run very smoothly. Right now, this runs pretty well. And now when we start drawing, then also the rotation will become a bit easier, because AutoCAD uses your last point for rotation. So here we'll snap on endpoint, and what I want to do now, I want to basically draw this curve, map this curve as we would with a prism on a stick. Enter. Oh, missed a few points. Let's move that. Just a second. Zoom in on that one. Select that one. Select this one. Move this one. What? Okay. We have the point cloud here in AutoCAD, but maybe, you know, if you ask me, I would still prefer to use 3Dsurvey for CAD functionality for drawing the curves. Okay, now the second part of the demonstration. So we checked how we can bring in the point clouds. So, and this goes for Civil 3D. It also, I think also ZVCAT supports import of RCS files. So in that case, the same workflow will apply. You can save, you can get the recap, convert those LAS files into RCS format, and then load them in. Now let's also check at how we can import surfaces into Civil 3D. So let's start with the next one. Okay, now let's check how we export a 2.5D mesh into AutoCAD. You should only use this technique for exporting 2.5D meshes because AutoCAD will not support full 3D mesh. So there are two ways to do it. First, we will show the simpler way, which actually takes a little bit longer. So the first way to do it is to right click on the mesh and save it into land.xml data format. Select the land.xml from the file type here. Let's go to AutoCAD exports and we will save it as dtm1.xml. Save. Right. Now let's go to AutoCAD Civil 3D, and here we will just use land.xml in command. Enter. Let's navigate to our folder. Select that file. Here we just confirm, press OK. Now this process will take a minute or 30 seconds, something like that. So if we have a very large surface, this process takes a little bit longer because reading from the XML is not that fast. Okay, and here we already have the result. So this is one way to do it. Let's try the other way, then we'll also have a quick look at what we can do with this surface. Okay, second way to do this same thing is go back here to 3Dsurvey and save the regular grid mesh as a txt file. So we'll select here txt ASCII data format and we'll save it as dtm2.txt. Save. This is how we will configure our format. So 3 decimal places will be enough. We don't need vertex color, just press save. Perfect. Let's go back to AutoCAD. Now here we will expand the surface data type. Right click on it, select create new surface. We will name the surface from txt file, for example. Okay. Then we expand this surface, expand the definition section. Then we click on this one and right click on add. Then we select the file that we have just exported from 3Dsurvey. Select that txt file. Now here it will be very important to select the file format. We need to specify it to be Eastinc, Northinc, Z, like that. Press OK, and we just had a second surface here. So this one we just created, so this one was, here we see that these two surfaces, they just have slightly different boundaries. So this is the first one from land XML. Right now we will just delete it and we will continue working with the other one. Right click on this one, delete. Yes. So now we are only left with this one. So what we can do with these surfaces, here under surface properties, we can choose this one, edit surface style. For example, we can set contour interval here in contour tabs. For example, we'll set it to 0.5 meter minor interval. That means that major interval will be 0.5 meter. We can change how contours are displayed. For example, we can use brown colors instead of gray. And use this one. For this one, let's use this color. Okay, apply. So by default we have two view modes. In top down we will see contours like that. If we rotate it, now we got into the other view. So if we want here to display contours instead of triangles, what we will do here, we will select edit surface style again, turn off the triangles, turn on border and contours, apply. So here again the contours are in default gray color. Okay, let's leave them like that. So, and this is how we brought in the surface into our AutoCAD drawing. What else? Okay, what else can we do with this surface? So if we select it, we can, for example, calculate some vertical cross sections. We can also do that in 3Dsurvey. We can extract some objects from it. So whatever is visible here, we can extract. So here, extract objects. So based on what's currently displayed, we can either extract border, major contours or minor contours. If we had triangles or points displayed, we could also extract those. So this is one way of how to get the contours into Dxf. So you can just do it like that. And now, even if we delete this surface, the contours will still be there. we can undo that. Now let's continue with the next part of the demonstration. Okay, so we just checked how to import surfaces into Civil 3D. So as I said at the beginning, this only goes for the 2.5D surfaces. 3.5D surfaces, or we should say full 3D surfaces, are not supported in Civil 3D. They might be in some more advanced programs like Revit. I don't use that one. If your architect uses it and you would like to give him the full 3D object, just save it into OBJ in 3Dsurvey and send him that OBJ. Now let's check out the final main data type, which is importing Orthos into AutoCAD. Okay, now let's have a look at how we export orthophoto data from 3Dsurvey into AutoCAD. So this data will be shown on a nice example that we received yesterday from our colleague Marco from RenderIt from Italy. So here we have a nice dataset with some buildings and some fields. We also made a digital terrain model for this area and of course an orthophoto map. So we have traditional orthophoto, we have an X-ray image. So this one can be also exported to the AutoCAD using the same workflow, and this one, you know, will help to extract the outlines of the buildings, for example, or maybe to draw these walls here or something like that. And we also have a through orthophoto map. Okay, now how do we export it? Well, here we have a few more options. First we will show Tif Export based on this X-ray. So again, to save it, just right click on the data, press Save As. We will save it here into exports. So if we select TIF file format, we have here some options. So pixel size, we can decrease pixel size, for example. We don't want this option. Split orthophoto, we just want one orthophoto. We can split it into blocks, for example 16 by 16,000 pixels, so that the other softwares won't struggle with the size of the orthophoto. But this one is not that big, it's less than 30,000, so we don't need to split it actually. Now here is the important part. Geo-referencing format, we have a few options. So if we are saving into TIF, we can use this one, GeoTIF data. That means that georeferencing information will be written in the TIF file itself. So let's do it like that. Press save. Wait a few seconds for it to save. And we will get the file. So TIF, the plus size from TIF file is that it has alpha. So here we have transparent background set when we calculated this X-ray. So, and that will allow us to also have transparent background in AutoCAD. The downside is that the file size can be pretty big. So just for this X-ray, the file size is 1 GB. Compare that to the point cloud that has the size less than 3 gigabytes, but it has a lot more data. Okay, let's bring that file now into Civil 3D. So if we have Civil 3D or AutoCAD map, we can then use map I insert command to bring in orthos or X-ray images. So here we just write map I insert, enter. Let's navigate to our folder. So this one. So in this case, the insertion point and the scale are red, and now this file will be imported automatically. So here under units for insertion point and density, let's leave it like that. Apply, okay, use zoom extends, and here is now our X-ray image. We can use this one, background transparency. That way we will be able to see through this image. So now basically all we get are these white lines. Then here you could then create a layer and just draw the outline in 2D for these buildings. Okay. Now let's check options we have with Jpeg export for Orthos. Let's go back to 3Dsurvey. For example, let's select the traditional orthophoto. Now this one we will save in Jpeg format. Save as. Here in exports folder, traditional orthophoto, Jpeg, save. Now here we have two geo-referencing options. First we will show what this Word file does. Turn off split orthophoto here as well, save. This one should export slightly faster. And the resulting orthophoto will be about 10% of the TIF size. So it makes a lot more sense to save orthos in JPEG than TIF or PNG. Now that Word file, that's the file that comes here. It has the same name as JPEG except for the extension. So if this one is JPEG, this one, the extension here will have first letter of the extension, last letter of the extension, and W. Inside there will be 4 important values. So first is the pixel size in north, south, so first one will be pixel size in east-west direction, pixel size in north-south direction, and the coordinates of top left corner. If we use map I insert command again here in AutoCAD, and we select that JPEG, then the Word file will also be automatically read. And we can just press OK to add this image in. So this is our ortho now. Before we brought in also the X-ray and set its background to transparent. If we, for example, move this image to the back now by selecting the Jpeg, clicking here display order, send to back, this has now brought it beneath the X-ray, so this should then help us. If we could also use this, you know, to draw exactly where we have the walls. So if we went to drawing lines, if we change our color, for example, to red, we could then use that, you know, just to draw the outline. So we can use that in connection with this for perfect marking of the building corners of Ortho walls. Okay, let's move back to 3Dsurvey. Here we also have the third option. We also have the true orthophoto. So here, when we will be saving this one, now we will choose again the Jpeg, but for geo-referencing mode we will select Dxf Frame. So why do we have this third option? So this one is here for users of other CAD softwares who don't support the mapI insert command, or for regular AutoCAD users, so non-map or non-Civil 3D, just regular AutoCAD or AutoCAD Lite. So that version is missing the mapI insert command, and if you use this option here, when you save the orthophoto, again an additional file will be created. This time that file is a DXF file that has the frame of this ortho inside it. Let's check. So here we have now our through orthophoto and we have the DX file to go with it. Now let's go to Civil 3D. Okay, now let's bring in that through orthophoto using the Dxf Frame. So first we will now use the insert command, and we will use this button here to select the Dxf Frame. Double click on it. Make sure that you have DXF selected here, because it defaults to DWG. So we need to set this one to DXF, select the Dxf Frame and press open. 0, 0 will be our insertion point. And if it also asks you for insertion scale, you should insert 1. Right. Zoom extends to our frame. Now let's attach the image inside of this frame. So we'll go here to Insert tab, press Attach. Now let's attach that through orthophoto. Oh, like that. Open. So in this case, we will specify the insertion point on screen, and we will also specify the scale on screen. So that's okay. For insertion point, we will use the lower left corner of our frame. And at first, we will just set the scale approximately like so. Click. Let's wait just a few seconds. Perfect, we have the image. Now let's just set the scale perfectly like so. Right click, and this is how we get our ortho inside of the frame. Right. Okay. Now let's bring in also the surface and point cloud. Surface, we'll just do it like that, create surface, add definition, so just like we did it earlier, just need to move to the correct folder. Please ignore that. Okay. And we also have our contour lines here. Let's also bring in our point cloud. Move to the correct folder again. Right. Okay. So here we have now point cloud, a surface, and ortho. Because we are looking from top down onto the point cloud, now basically we can't see the point cloud, but if we were to draw a line here, we would actually be drawing in 3D because we would be snapping to point cloud points. So you see that the new point here will also have an altitude of 34 point, let's say 78 meters. So of course for production we would zoom in more. Now we are able to see the points. So this is then one way of how we could draw the survey map in 3D. If we rotate our view just a little bit, let's close that. Now we see that we have the surface over the ortho, and we can see the whole point cloud. If I let it go now, now the surface has changed to solid. So then, there's another thing we can do with this surface. Just leave it a little bit. If we select it like that, also this is now actually the point cloud. Let's select the surface here. We can drape the ortho image onto it. So this image, drape it on that and use it as a render material. Okay. Now we will just need, I think, to change the display type from 3D wireframe to solid. We'll do that like that. Or realistic. Let's give it a few seconds for it to update. Okay, now the texture is applied. And now we could also draw on the 3D surface here. Okay, it started to respond. Zoom in now. Now we get a better, more realistic view here in AutoCAD. So this could be a good way to make the map. It certainly offers a very realistic visualization of this area of interest. Right. So we checked the three ways how to bring in ortho image into Civil 3D. Now let's continue with our demonstration. Right. Now for three additional tricks. So the last part of this session before Q&A, let's also look at the options we have when we export contours, when we export vertical cross sections, and let's also look at the options we have for converting points in Dxf format into Dxf. Right, let's see how this goes. So first we will look at how we can export contours and the two options we have there. So if I go to the contours tab, so when we export the contours, we will want to use this option, show height. So this will also add the elevations to the Dxf file. Then we use this option, export Dxf, and you see that here we have two options, either 2D or 3D export. So if we export it in 2D, like that, just write contours 2D. Right, let's bring this into AutoCAD. Change folder accordingly. Zero insertion scale, and in my case that's it. Zoom extends. And here are our contours, so they are in 2D, so basically they are now flat. Let's delete those. Now let's use the second option. Go back to 3Dsurvey, export Dxf, and let's export them into 3D data format. We'll use the same name, except here it will say 3D, save. Now let's bring those in. Again, the insertion point is 0, 0. Right. Now let's bring those in. Contours 3D, 0, 0 for insertion scale. And now we have here our contours in 3D. I think this looks a little bit better because we have better display options, but I know some people who usually work in 2D prefer their contours to also be exported in 2D. And that's basically all there is to it. Now let's go to the second part of this final demonstration. Back to 3Dsurvey. Here we also have some vertical cross sections. And here are these cross sections in profile view. So if we export this into Dxf, so I'll just write here profiles.dxf. Perfect. The file is saved. If we bring that one in here into AutoCAD, so this time we can set insertion point will be at 0, 0, 0, scale 1, rotation like that. We can all, let's keep it, let's explode also that part. Bring in that Dxf. Now we specified the insertion point here. So in this case, two things are inserted. So first one is here we have the vertical cross sections in 3D. So they are at the exact position where we have them here in 3Dsurvey. If we rotate it just a little bit, we see the 3D vertical cross sections. One thing I actually recommend you to do is, here you see, so with the profiles we also export the points which were used to define the profile. Oh, these aren't strictly necessary. We can use this one, select similar, to select all of them and then just press delete. We'll do that on all the cross sections right now, like that. Left select, select similar, delete. Now we should be left with the profiles only. Perfect. So here at the exact coordinates we now have the cross sections. We also have the profile views, but this will be here close to 0, 0. So we can either take what we need, or we can take this and move them and place them here close to our drawing, maybe here, like that. Maybe increase scale. How we do that? Scale, maybe make them a little bit bigger. Okay, something like that. And that is how we bring in the vertical cross sections. Right. Now there is just one additional trick I want to show you. Now, every land surveyor already has a way of bringing points in TXT format into CAD software. So one way how this can be done, it can be also done with 3Dsurvey. So here we can go to data, load CAD, and we can select a TXT file with some points inside. So point name XYZ data format. Double click to select. Here we can set the XYZ values. So you can actually use this tool if you would want to convert some points. I can show you that later. But right now we will just be bringing these points in. Press import. And here they are now in 3D. So now for these points we can save them into Dxf format. Save, measured points Dxf. And we can now bring these points into Civil 3D. So here we will just use insert command again, it's still open, press here, select the measure points Dxf, and now these points are in here. So the points are not really shown, they are hard to see because they are just nodes. So everything is put on a separate layer. So here we have, let's go to layer properties. Civil 3D gives you a lot of layers by default. Let's do it like that. Find our measured point. Let's make it better visible, maybe bright yellow color. Okay, so now we see the point. Here we can also change the color of point altitudes or point numbers, so they are all on separate layers. And if you want to change this sign, ddp type is the command, or p type, and we can select, for example, this one. If you use regen, it will update the size. Okay, we could play with that. Now, just the last thing I want to show you. So this is how you just import the points, but let's say that those points are in, for example, a geographic coordinate system, and you would want to convert them into a UTM coordinate system, for example. I'll just start a new window of 3Dsurvey, go here to data, load, select these points. So these points here are obviously in latitude, longitude, elevation format. So what we can do here, we can use this one, known projection, in order to convert these points. So here we will now select a geographic coordinate system. 99% of the time we will be converting from WGS 84 coordinate system, and we want this in UTM, so Universal Transverse Mercator. If we do that, then it's also imperative that here we set these columns correctly, so it won't allow us to do that if here is set to XYZ. We have to say this one is latitude, this one is longitude, and this one is altitude. Now we can import, and here are our points. Then we can simply save them into UTM, so we'll just write points UTM like that, save, and we have just converted points from longitude latitude to UTM data format, and that way we can then bring them into Civil 3D or any other CAD software. Okay. Right. Now let's go to our questions and answers session. So we have two good questions from Eduardo Silva. If any others have any questions, now is the correct time to ask them. So his first question is, I'll just make a screenshot here real quickly, like that. Wait, let's go like that, out of this one. Here I have a screenshot with the questions that were asked. For now, so first one is, hello, how do you export the DSM to Civil when the project has a logo of trees and buildings and see clean counters from the terrain? So I'm thinking, if I understand the question correctly, this is what you are interested in, to have the DSM model. So if this is it, then this functionality again is coming with one of the future versions. So for through orthophoto, we will also add support for this kind of algorithm where you will have DSM with the buildings on the irregular grid network. So stay tuned for this one. Let's go back to the questions. We had some comments about sound. I hope that most of you were able to hear the sound. If not, you can always check the recording. Everyone who attended this webinar should get the recording. I think it will arrive today in a few hours. Once it finishes processing, then everyone gets it. So if you have problems with the sound, try opening that recording. If it still doesn't work, try opening it on another device. Then we have a second question from Eduardo, how to export cat points to TXT file with description. Good question. So I have already prepared here some points. So here we have first point is without description, and then for points 2, 3, 4, 5, we added some text. So we use this one, we use the code. Maybe we can say, okay, this one is GCP. That way we can make points with description. Now, when we are saving these points, when we go data, save cat as, if we select TXT here, press save, yes. Then just make sure to include this checkbox here, point code. Okay, press save. Okay, here we have our points. And now you will see that these points, they also have the description here. Now, if we save these points into Dxf, you will get the description on a separate layer. I think it will be in blue color. Okay, let's go back to the questions. So Dave Scott has asked for the recording. No problem, Dave, everyone gets it. Just a second. Let's make a new screenshot of the questions. Like that. Hello, how can I remove vegetable to get elevation at there? So if you want to remove high objects and vegetation, just use the classification algorithm. So here, this is already classified. So if I click redo, it deletes the points that are not ground. For more information on how to do the classification, we have a nice webinar here. If you go to our webpage, www.3dsurvey.si, under Learn Master, here is a section on classification, point cloud classification. Just check this video, okay? Okay, So video webinars and the recordings are really useful, but do you have plans on building a comprehensive and updated online manual for easy and quick referencing? Yes, we actually have a plan to do that, and we plan to do that this summer. So we will have one guy coming, and his main task will be exactly that. Let's see if we have any new questions. Just a second. Questions? How about MicroStation from Bentley? Well, I think some of these techniques might apply to MicroStation as well. I haven't, I don't really know it, or I haven't ever used it, so I can't say for sure. So at this point, we do not plan to do the same just because we don't know that program. I know AutoCAD because I worked with it for a long time, even when I was studying and these kind of things. And then at the beginning, when we were developing 3Dsurvey, we also used AutoCAD a lot. But MicroStation, I know that it's also one very popular software. I know that it's very similar to AutoCAD. It was developed, I think it's originally developed by the same team, but unfortunately, I really don't know how to use it. Okay, I think these are all the questions that we had for today. I would like to thank all of you for attending this webinar. Thanks for joining us, and looking forward to see you again. And bye-bye for now. And before we finish, I see that we just received another question really quickly, which we will take time to answer. I want to include the limit of the terrain into point cloud. In Civil 3D, I transform the line into points and then I import them to 3Dsurvey, but couldn't change the color on this from that point. So I use Cloud Compare to do that, but of course, like to use 3Dsurvey for that process. Is that possible? I'm not sure if I understand this question. Maybe Eduardo, you can send an email on this subject on our support email. I will answer it there, and we can set up an online session, and we can check exactly what your workflow in Cloud Compare is, and we try to do then everything in 3Dsurvey together. I hope that will be okay. So another question we have just received is, how well does it work with microsurvey embedded CAD? Sorry, I don't really know the microsurvey embedded CAD, so I can't exactly tell you. But if you need, John, I can send you some test data and you can try to load it into that CAD solution. So, okay, I think now we have really gotten to the end of the question. So thanks again for attending this webinar, and see you on the next one. Bye-bye.